alleles. So here we see is a diagram of a different variety of traits. We have dominant and we have the recessive. The dominant tends to be more common, so that's why they're dominant. And the recessive sometimes skip generation and they're not as common, so they're known as recessive. These things that we see, we're able to observe, we call these things phenotype. So here we have green peas versus the yellow peas. Those are the ones we can observe. What are they called? Phenotype. Whereas the letter, for example, the green have big G, and the yellow have big G, small g, those are the genotype. Genotype and phenotype does not necessarily go together all the time. For example, big G could be green, or big G could be green. Because the G is dominant, the green is displayed as the phenotype, the physical. So when you have a big G and a big G, the allele is going to separate one G here, and when you cross it with the yellow one, you have a G here and a small g here. When you cross them together, you take one from each parent and you put them together, then you determine the phenotype. And you repeat this for all the other square. So you see that when you cross a normal parent with 2 big G and a recessive parent with 2 small g, you would get the kids for the genotype would be all heterozygous, meaning one big and one small. And for the phenotype, they would be all green. Let's see what happened when we cross something else. Over here, we have another green, but this time, this one is a heterozygous, meaning a big G and a small g, whereas the other parents are small g and small g. When we cross them together, this gives a big G and a small g. However, this will give a small g and a small g. And then you fill up the other boxes. So you have 2 that are heterozygous and they're phenotypically green. And you have 2 that are both recessive and they're both yellow. So there's a 50-50 chance of being normal versus being recessive if you have a parent that is heterozygous crossed with a recessive parent. We'll pick up more on that later. So this whole work of crossing and figuring out what happened, what if, is a diagram called a Punnett square used by scientists to determine the possibility of the future generation. So for example, if you were normal and you married to someone who is recessive to a gene, for example, let's call this tall and this short, chances are your kids, 100% of them, will be perfectly normal. However, they will be carrier of the short gene. So maybe in their next generation, they might have short kids. And over here, if you are normal but you're heterozygous, meaning you are tall, but you also carry a short gene and you marry another person who is short, chances are 50% of your kids will be normal and 50% of them will be short. So what you're determining using a Punnett square is the probability, the chances of something happening, the chances of what you may get. Colors or height or any of those things are called gene. Inside each gene, there are different forms of a gene. For example, green, you can have big G or big G small g and you can still be green. These letters in science, they don't call them letters, they call them alleles, which means different form of a gene. For example, one gene type could be about height. The allele would be tall or short. And the genotype is big T or small t. Another gene could be about color, and the allele, the different form of color you can get, for example, would be green or yellow. And that could be a big G or small g. So the gene is what is the trait about height or about color, and the allele is the form of it. Different form of height could be tall or short, different form of color could be green or yellow, and the genotype is somewhat similar to allele. Genotype just means all about the letters and such. But remember, we don't call them letters. We call them alleles. When you have two letters that are the same, two alleles that are the same, it's called homozygous. The word zygous from the word zygote, which means together, and homo mean the same. So when they are together and the same, they are homozygous. This one is also homozygous. This one is not homozygous. This is a homozygous dominant. This is a homozygous recessive. Let's figure out what this one is. This is called a heterozygous. Hetero means different. They are together, but they are different. What are these called again? Homozygous. And they are also dominant. These are homozygous and recessive. These are heterozygous. When they are heterozygous, you don't necessarily have to call them dominant or recessive. Heterozygous simply imply that they are different. Worms after the rain. Notice how worm comes out after the rain. The reason is because their skin is different from us. When they breathe, they don't breathe through the nose like we do. They breathe through the skin. So technically, throughout the whole body is breathing. But in order for them to breathe normally, the environment around them have to be moist. Otherwise, it's going to dry up and they're going to die. So after the rain, the worms will crawl up into the surface because the surface will now, the air will be moist. It's easier for them to be in the surface when it's moist in the air. Why would they want to come up to the surface when they could just stay underground to keep it moist? Well, the reason is because to find a mate. So worms crawl up to the surface when it rains to find a mate. Oh yes, that's right. Worms mating on the ground, in the rain where it's all wet, in public. And you thought the back of the car was bad enough? Think again. So, how do you find your mate?